Alright, so in this step what we're going to do is use the optimizer, the solver, to create an optimum bond portfolio. For my example, my target is 8.5 years in terms of duration, and my target value is $400,000. And what we want to do is select bonds in such a way that we minimize our upfront investment, yet at the same time hit our target value, in my case 400,000, and our target duration. What I've done here is simply pulled over the bond that I'm interested in. I've set it equal to the price I'm interested in. I've pulled over the contribution, and I've pulled over the duration. These numbers right here, you're just going to start with, say, 1, 1, 1, and 1. Our cost is just the number of bonds times the price it comes in. And we do that for each one of these guys, and then we sum them up and take the negative value. We want to minimize it, not make it highly negative, so we take the negative value. The contribution is simply the number of bonds that I'm purchasing times the contribution for each bond. And the duration is the number of bonds that I'm going to buy multiplied by the contribution of each bond multiplied by the duration of each bond divided by the sum of all the contributions, so the total portfolio value. Notice that that one is dollar signed out because it doesn't change. Alright, so that's the setup here. And what I want is a nice, neat table, not a reproduction of what you see here, but a nice, neat table that conveys all the information that you think should be in there. If all you give me is a printout of this table, expect to see negative points. You're going to get a lower grade. So we come over here to data and we bring up our solver. So what do we want to do? We actually want to, our solver is set here for the cost. We want to minimize the cost. So we want the cheapest amount of money to come in by changing these counts subject to these underlying constraints, and we're going to go over a couple of the constraints. So one of the first constraints here is that F3, so here's F3, it's got to be less than or equal to 100. We have to have a diversified bond portfolio. If you give me a portfolio where 99% of the value is contained in one or two of these bonds, expect a lower grade. I want to see a nice diversified portfolio. F3's got to be greater than or equal to 5, so I need a minimum number of bonds there. I also don't want to see, you're going to have to put a table together of the constraints, and what I don't want to see is just a reproduction of what I've done. I put some thought into it in order to change these things around. Next constraint is that F3 through F7 have to be integer. So in order, just to show you how you do, you set F3, highlight the box that you're interested in, and all you're going to do is pick integer. And I'm going to hit OK to edit it. So that means that these got to be integer values. You can't buy a fraction of a bond. The rest of the constraints are saying that all the values got to be less than 100 and greater than 5. And then here, for the portfolio value, my target is 400,000. Your target is going to be 600,000. So I can't necessarily get exactly to 400,000. So I need to give it a little bit of range. And what I've done is gone plus or minus 5,000 from it. We can actually, if I wanted to, I can edit that. Click on change. And so instead of 5,000, maybe I go plus or minus 3,000, for example. So this would be 397,000 instead of, so I'm within 3,000, plus or minus 3,000 of the target. And there, again, there has to be some fluctuation associated with it. Alright, so with all my constraints set, what I want to do is go ahead and solve it. and I'll keep the solver solution. So this is the solution here. I've gotten to 397,000, which is pretty close. You'll notice that the 100 bonds here, 73 here, 83 here. So my diversification is kind of suffering a little bit. In other words, I only got 8 and 6 of 2 of the bonds. That's really kind of low. There's not a hard and fast rule I'm going to apply here, but something like this I would consider to be less than perfectly diversified. One of the biggest things you can do is to go ahead and open your range up is one thing. So here I'm going to go back just to show you the difference. This is going to go back to 5,000, and I'm going to change this one back to 395. So with my new range, I'm going to go ahead and hit solve. Let's go. Try it again. So this is giving me a little bit different range in terms of falling in. I'm a little bit lower on my price, 16 and 20, more diversified. Another option that I can select in order to keep things being diversified on the solver is, instead of having this one at 5, I can change it to say a minimum of 15. So I'm going to change all my lower constraints, or a couple of my lower constraints here, to 15. All right, and then go ahead and hit the solve again. Now, since I'm already over 15, maybe I needed to go to 20, etc. All right, so I think you got the gist here. The other constraint that you need to do, if I look at my solver, pull down, is that my duration, in your case it's 9.5, mine's 8.5. You got to, again, give it a little bit of room. So less than 8.51, more than 8.49, and get it to fall in. There are multiple solutions. You can also over-constrain the model so that you're not getting things sufficiently close. In other words, there's no functional solution to it. This looks a little more diversified. Is a simple potential solution. That's going to be F3. Again, maybe 100. I mean, 100 is pretty high here. So if IBM runs into a problem, you know, a significant chunk, $135,000 from my portfolio isn't going to be working out too well. So maybe I want to take that one and change it and make it less than 75. And then do the solution again. So here's a new, that's pretty well diversified portfolio. You notice my price has gone up. It's costing $300,000. You give me $300,000 today. In the future, I'm going to give you $397,174 back. All right, so that's the optimization routine. Take some time to do work on it. Again, you need 10 bonds as opposed to my 5. And thank you very much.